So, the second trig review video really isn't a review. A lot of this will be stuff that you haven't learned before. So, very important in going forward with the unit circle, which we'll learn in a couple days. So let's just define some initial angle definitions. We're going to define an angle based on a coordinate plane. So a standard position. If the vertex is at the origin and one ray or one side of the angle is the x-axis, the x-axis would be called the initial side. This side would be called the terminal side. So let's just get this. This is a standard position. This is called the initial side, and this is called the terminal side. And again, the vertex must be the origin, and the initial side must be laying on the x-axis. We also know the measurement of degrees as we go around. This would be 0, this would be 90 up here. That didn't work. This would be 180 over here. This would be 270. And coming back around, this could also be referred to as 360. So let's draw some angles in standard position. Let's start with the angle 220. So I know the vertex is here in the middle, and I know this is the initial side. And 220, we measure angles counterclockwise. So 220, well, if I go to here, it's 180. So I'm going to have to go a little bit past 180. Here would be the terminal side. This amount passed is, I'm totally judging it. I'm not getting out a protractor. So how many degrees am I past 180? Well, this would be 40 degrees. Just past 180. So this would be a picture of a 220 degree angle. Okay, what about 510? Well, 510, again, initial side and vertex. Okay, if I go all the way around, I'm going to 360. We go a little bit more to 90, and that's still not 500 because that's 360 plus 90, which would be 450. So 510 is about 60 past that. And that probably was a little bit too far. But this would be the terminal side of 510, where this amount in here is about, whoops, sorry. It's about 150 degrees past the 180. And I apologize for the stylus. So this would be 150 degrees past the 360. We can also measure negative angles. So again, the vertex is going to be at the origin. The initial side is going to be on the x-axis, but this time we're going to measure backwards to 100 degrees. That would be 90. Go back a little bit further, and here would be the terminal side of a negative 100 degrees. So now we have another term that we need to learn, and it is this word down here, coterminal. We are looking for a positive and a negative angle that are coterminal with 45. We know that 45 degrees is about right here. So coterminal means they share a terminal side. So this guy right here is 45 degrees. A positive angle would start at the initial side and wrap all the way around back to that positive angle. So that would be 360 plus 45, which would be 405. A negative coterminal angle would start at the initial side and go backwards to the terminal side. So that would be 270 plus 45. That would be 315, but since we went backwards, it would be negative 315. Okay, let's try it again. Find a positive and negative angle that are coterminal with negative 110 degrees. I'd love for you to pause and try to do this on your own and then check your answers. So, negative 110 is a little more than 90, so this would be negative 110. I want a positive angle, so I'm going to start at the initial side and go counterclockwise to get positive. Now, the interesting thing is this distance in here would be 90 to 110 is 20. But I don't want to know that distance. I need to know the distance in here where the red part is. So this distance would be 90 minus 20, which would be 70. So my positive is 180 plus that 70, which would give us 250 degrees. The negative coterminal, well, I'm going to start on the initial side, and I hit it, but this is what I started with, so I'm going to go all the way back around and come back to that negative. That would be a negative angle that's coterminal with negative 110. So we went 360 backwards, we went another 90, and we went another 20. So this angle would have degree negative 470. So this, would be my positive, and this would be my negative coterminal angles. All right, we all know that there are many ways to measure things, using feet, using inches, using yards, but I can also measure something using strides. I can also use something, measure something using millimeters. Radian measure is another way to measure the angles. And radians are measured like this. Circumference is 2 pi r, which means that there are 2 pi radians in a complete circle. And I denote circle with a circle and a dot in the middle. So 180 degrees then would be pi radians, and 360 degrees is 2 pi radians. So what would 90 degrees be, and what would 270 degrees be? 90 degrees would be pi divided by 2 radians, and 270 would be 1.5 pi, so 3 pi over 2 radians. Okay, so how do I convert degrees to radians? I'm going to take 135 and I'm going to multiply by pi over 180. Kind of doing dimensional analysis with radians and degrees. This will reduce to 3 pi over 4. How do I convert 5 pi over 4 to degrees? I multiply by 180 over pi, which would be 225 degrees. Notice in both of these, as I multiply, here I'm going to add a pi, which is what I need for radians. And here I'm going to delete a pi, which is what I need to do to get to degrees. Two old words from geometry last year are arc length and area of sector. So remember that a sector is actually a piece of the pie, like this green that I'm coloring in. The arc length is just the blue right here that gives me a piece of the circumference. So arc length and sector. And when I'm given a theta, I have two formulas. The arc length let's spell that correctly. Arc length would be S equals R times theta. And the area of a sector would be 1/2 R squared theta. This is area of a sector. Okay, last thing we need to talk about is arc length and area of a sector when you're given theta, a central angle. So let's just look at this picture and remember some terms. A central angle is an angle that comes from the origin of the circle, the center of the circle. So this would be a central angle. It comes from the center, as opposed to an angle that doesn't come from the center. We're going to refer to that angle as theta, and S is going to be the arc length. So what S actually is, it's an arc length, it's a piece of the circumference. It's this piece of circumference. So there are two formulas that you'll need to learn. Arc length is S equals the radius times theta, and theta is in radians. And the area of the sector is area equals 1/2 R squared theta, where again, theta is in radians. So I like the example from the book. I want to know the length of the outfield fence. So I also want to find the area of the field. So the first thing I know is that my 90 degrees has to be in radians. So I'm going to multiply by pi over 180, which is going to give me pi over 2 radians. So this central angle is pi over 2 radians. Now I'm going to find the arc length. So again, the arc length is S equals the radius times pi over 2 radians. That is going to give me 90 pi. So if I substitute pi about 3.14 in there, the length of that outfield fence is going to be about, about 283 feet. Okay, and I'm going to find the area of the field. The area of the field is 1/2 R squared theta, which is going to be about 8,100 pi, well, which is 8,100 pi, but if I approximate pi, that's about 25,400 feet squared.